All right, so last video we saw we went through a few examples of statistical hypothesis testing on two samples, and so now what we're going to do is continue that theme. I want to remind you again what we did last time was the two sample z-test, the two sample t-test. The difference between Z and T, just like last chapter, is whether I know my population standard deviation or whether I don't, and I only know my sample standard deviation. So we're going to go today and look at the other tests. We're going to look at, first off, what sort of Z and T tests, how we can sort of give you curveballs on that. We're going to look at proportion tests, and then remember the one more test when we have paired data. So we're utilizing that, those tests here. So we left off with example 5. We did example 5, and that was about the average corn yields in northern Michigan, north and central Michigan, versus in the southern Michigan counties. So we want to start this video by saying, well, what if we had been given raw data? So we look at example 6 here. It says a healthcare worker wishes to see if the average number of family daycare homes is greater than the average number of daycare centers per county. The number of centers for a select number of counties is shown. At alpha equals 0.01, can it be concluded that the average number of daycare homes is greater than the average number of daycare centers? So in this case, we're given raw data. Now, our raw data here is not paired. Okay, remember if you recall, we had 4 tests, the 3 tests that mimic our chapter 9 and chapter 8, and then the 4th test, which is the paired data. This data, while it is raw data, it is not paired. We don't know that this 25 is associated with the 16 or the 25 is associated with the 14. So we just have 1, 2, 3, 4, 5, 6 different samples of family daycare homes, and 1, 2, 3, 4, 5, 6, 7, 8 samples of daycare centers. And so what we're going to do, since we just have been given raw data, notice I do not have any population standard deviations. So I'll end up with having sample standard deviations from the samples, but I don't have populations. So that means I want to use a 2-sample t-test when I go about and do this. Now before, and like always, before we actually get into doing the actual test, we want to set this up. So we're going to set this up. The null hypothesis, well, we're saying if the average number of daycare homes is greater than the average number of daycare centers. All right. So we'll call the daycare homes my group 1 and the daycare centers my group 2. Remember from last time that when you're doing this, the null hypothesis always has the equality. So the null hypothesis is going to be the average number of daycare homes. Let me just write that down. Homes is group 1. The centers are group 2. Okay? So average number of daycare homes is equal to the average number of daycare centers versus now our alternative hypothesis, average number of daycare homes is greater than the average number of daycare centers. Oops, hit the wrong button there. All right, so my null and alternative hypothesis are this. Now we're going to end up doing a 2-sample t-test for the reasons I stated earlier. We don't have any population standard deviations given to me, so we'll end up with just the sample standard deviations that come from these 2 samples. Now, when I go into the 2-sample t-test, I'm not going to go in there quite yet. Since I'm given raw data, I'm going to put this raw data into my calculator. And probably the easiest way to do this is I put homes as group 1. So put 25, 57, 34, 42, 21, and 44 into your list 1. So list 1 on the calculator is going to be whatever goes into group 1. List 2 on my calculator is whatever is in group 2. So the 16, 14, etc., etc. So go ahead and do that as we talk. The list 1 should have 6 entries. List 2 should have 8 entries. If you need to slow it down, you can always push pause on the video. And then we go to our 2-sample t-tests. So again, list 1, daycare homes. List 2, daycare centers. Then we go to tests, 2-sample t-tests. That's down in number 4. Excuse me. 2-sample t-tests. This is where your inputs want to be data. So you make your inputs data, and then just like it says on the screen, it'll pop up as list 1. Again, list 1 we associate with group 1. So we put that in L1. List 2 we associate with group 2. We put that in L2. It gets a little bit confusing if you make your list 2 L3 and it's associated with group 2. It just, again, so associate with group 1 L1, associate with group 2 L2. Our frequencies we're just going to label, just like we did last chapter, as the number 1. So the number 1 is our frequency, and then greater than is my alternative hypothesis. We choose not pooled, so no on the pooled, and then we go ahead and calculate. Now before I click off this, let me just once again say that's the inputs. All right, and now we have it. So calculate, and you should get a p-value of 0.0458. At least that's what I got. Hopefully, either I didn't make a mistake or you didn't make a mistake. But what we see is this p-value, 0.0458, we compare with our alpha as 0.01. So my p-value is greater than alpha. 0.0458 is greater than 0.01. So my conclusion is to do not reject the null hypothesis, H0. Again, if you want to write out the words null hypothesis, that's fine. Okay, so do not reject the null hypothesis. If I don't reject the null hypothesis, let's highlight that. What am I saying? I'm saying that the average number of daycare homes is close to the average number of daycare centers. Remember that phrase, we don't want to use equal to, we want to use close to, just like we did in the last chapter. So it looks like this. The average number of daycare homes is close to the average number of daycare centers. If you want to be a little bit more specific, you could have You could have said the average number of family daycare homes is close to the average number of daycare centers. But that's it. That's what we have to deal with. So hopefully that makes sense, that if we just have raw data that is not paired up, then we just use list 1 and list 2 of our calculator. We let group 1 be L1, group 2 be L2, and then utilize that. Now, the next problem changes. It says, as an aid for improving students' study habits, 9 students were randomly selected to attend a seminar on the importance of educational life. The table shows the number of hours each student per week before and after the seminar. The number of hours each student should say studied per week. There's a typo there. Oops. Let me go student studied per week. Sorry about that. We will change that. Before and after the seminar. At alpha equals 0.01, did attending the seminar increase the number of hours the students studied per week? Now, here's the case where we have paired data. So if you think about this, what we have is we have a study that looked at the same students before and after. That means we don't actually have 2 different groups. We have one group that was sampled twice. Okay, so this is the idea of paired data, sort of before and after data. So we took a survey before, we surveyed the exact same people afterwards. And what we're looking for here is how much change there was, or how much difference there was in this. So here's what we end up doing. Instead of treating these as 2 different groups, we realize that these are the same group studied twice. And so we look at how much change there was between our first and our second measurements. So here we go. So let's look at how much change there was. And I'm going to create a third row here to look at the differences or the change. I'll put difference here. Notice that going from 9 to 9 is no change. So numerically, that would be 0 difference. Going from 12 to 17. Now there's 2 ways to do this. I'm going to call that a positive 5 because that's an increase of 5 hours studied. Going from 6 to 9, that's an increase of 3 hours studied. Going from 15 to 20, that's an increase of 5. So all of those are positives. In other words, positive means the student studied more. Going from 3 to 2, that's a change of 1, but it's in the negative direction. This individual went from studying 3 before to studying 2 after. 18 to 21, that's a change of positive 3. 10 to 15, that's a change of positive 5. 13 to 22, that's a change of 9. 7 to 6, that's also a change of negative 1. So what we're looking at is, did the seminar increase the number of hours studied per week? So what does that mean? That means an increase means that the difference would have been positive. Like 12 to 17, that was an increase of 5. So here's how we set this up. What we do is we realize that we are back in the one sample hypothesis testing. And we start looking at the differences. Sometimes what I'll do is I'll just say, well, the average of the differences is equal to 0. Other times you can leave the d off, but mu sub d just means average of the differences. Now, what does the average of differences mean equal to 0 mean? This means there was no change on average. So on average, there was no change. Again, notice that you go from 9 to 9, that's a difference of 0. So that's a good example of what the difference of 0 means. And you're looking to see if there was an increase. Well, what would an increase mean for the differences? An increase for the differences would mean that, actually I'll do the same thing, mu of d greater than 0. In other words, we're getting positive numbers when there's an increase, right? So this, our alternative hypothesis, average of the differences is greater than 0, okay? Again, we basically crunch this table down, we erase the before and the after, and all we're looking at is the differences. And the null hypothesis is that there was no change. No change would mean 0 difference. An increase would be a positive, so it would be greater than 0. If it were a decrease, we would use less than 0. Now, notice we're only dealing with one sample equal to a number. That means we're utilizing our t-test. And by t-test, I mean my t-test that we used way back in chapter 9. Okay, it wasn't that long ago. But t-test, so it's the one sample t-test, that's number 2 on your calculator. And what we're going to end up doing is we're going to end up putting a difference. Notice how we have a raw data here. This difference row is going to go into, let's say, list 1 of my calculator. So we go stats, edit. List 1 is going to take the differences. So it's going to go 0, 5, 3, 5, negative 1, 3, 5, 9, negative 1. All right. Again, the only thing I'm putting into my calculator is, in fact, the differences. Let me show you that real quick. Into list 1 goes the differences. Okay? And you do need to have your negatives when you need that. So then after we get that raw data in, then we can go to the t-test. That's number 2 on our calculator. We're going to have an input. I have data, so we're going to input data. That mu sub 0 is always the number in the null hypothesis. That's 0 in my case. The list is L1, the frequency is 1, and we're going to use greater than 0 for the alternative hypothesis. So as far as what your calculator should look like, let me flash that up there. Whoops. Your calculator screen looks something like that. Calculate that, and you should end up with a p-value of 0.0116. 0.0116. All right. Now that p-value, let's look at what alpha is. Alpha is 0.10. So this p-value is less than alpha. There we go. P is less than alpha. So P less than alpha means we should reject the null hypothesis, reject H0. And if I reject H0, basically I'm saying H0 can't happen. So the alternative hypothesis must be happening. All right. I'll highlight that, but you don't have to worry about that if you can't see it. The alternative hypothesis must happen. Now, here's a weird way, again, what this is saying is that the average of the differences is greater than 0. Now, in layman's language, what's that mean? Essentially means on average, there was an increase, okay? So that's all we have to say. On average, there was an increase in time spent studying after the seminar. Okay, there was an increase in time spent studying. So that's all we have to say. Again, this is a little bit different phrasing. With the paired data, it's hard to really interpret, it's hard to state this directly. So we just have to realize greater than 0 is an increase, equal to 0, we would say on average we stayed the same or we stayed close to the same. Less than 0 would be decrease. So the average time spent studying greater than 0 means did increase after the seminar. All right. So hopefully you understand that. Again, if you need to, push pause, go back, try it out, those types of things. What I'd like you to do is push pause on the video and try to read and do this problem here. All right, hopefully you went ahead and did that. This one takes a little bit of time because we have to do the subtraction and all that kind of good stuff, but very, very similar to what we had, before. Excuse me. Okay, so first off, let's start out utilizing the null, or excuse me, writing the null and the alternative hypothesis. Okay. Now, even before we do that, let's make our difference row here. Now, I want to be very careful how I subtract. Okay. What I do always is I say, well, going from before to after is a change of, well, in this case, 6.6 to 6.8. That's a positive 0.2. Notice that going from 6.5 to 2.4 is a change of negative 4.1. So any decreases, I'm going to consider as negative numbers. Any increases, I'm going to consider as positive numbers. I always think that's a little bit easier to deal with. Negatives mean decrease, positives mean increase. So negative 4.1, that's going to be a negative 1.6. Uh-oh. There we go. D here, that's going to be a negative 1.8. E is going to be a negative 3.2. Hopefully I'm doing these all correctly. F is going to be a negative 2. G is going to be a negative 2.9. And when I subtract my H, it's going to be a negative 9.6. That's a pretty big decrease. Okay, so basically, notice I have the majority of these are negatives. Other than that A, everything else is negative because everything else was a decrease from before to after. Now, the null hypothesis, mu of the differences, the average of the differences is equal to 0. Again, equal to 0 means there's no change on average, versus we're looking for if we get less pain, all right? So are they lower after hypnotism? Are they lower? So is the average, is the average of the differences a decrease would mean less than 0. Okay, so again, everything lower is always less than 0, greater than is always greater than 0, the way I do it. The test we're going to utilize is, again, a t-test. That is just a one sample t-test. So hopefully we go and we've put these differences into our list 1. I've done that. So put the differences into list 1. We're going to input data. My mu sub 0 is 0. My list L1. We're going to look for a decrease. So when you ask for the alternative hypothesis, it's going to be less than 0. Let me show that to you real quick. So that's the screen. Hit enter on your calculate. You should get 0.0095 as the p-value. 0.0095. All right, so t-tests with data, and we're getting that. Now, that p-value, we tested the 5% level of significance. That means alpha is 0.05. So in this case, we scroll over, we go p is less, p is less than alpha. So every time p is less than alpha, we reject the null hypothesis. Now again, we reject the null hypothesis, so we don't want to, the null hypothesis we say is wrong, so the alternative hypothesis must be correct. And what we would say here is that on average, the pain scores did decrease after hypnotism, or were lower after hypnotism. The pain scores decreased after hypnotism. Okay? Again, we're saying on average. Make sure you have that on average there to start with. Don't forget what we did in the previous part of this chapter. Okay, the average something for this group was different than the average something for the other group. So there we go. On average, the pain scores decreased after hypnotism, or you can say the pain scores were lower after hypnotism, something of that nature. Now, one thing here, this alternative hypothesis was what we concluded. We say the null hypothesis did not. If we did conclude if we said do not reject the null hypothesis, my interpretation statement would go something like this. We would say, on average, there was close to no difference before and after hypnotism. All right, so if my null hypothesis was not rejected, that's how we'd phrase it. Okay, obviously in this case, that wasn't the case. So hopefully paired data makes sense. Basically, you turn back to what we did in the last chapter, and we say, well, this is just a pair of data, so we create another row of differences. All right. So now we're going to move on. We've done our 2-sample z-test. We've done our 2-sample t-test. Now we're going to move on to the final type of test, which is our proportion test. So this says in a sample in a 2017, a sample of 357 males from the boomers generation showed that 75 had been veterans. a sample of 700 males from the millennials generation showed that 28 had been veterans. By the way, if you want to know how Pew Research defined boomer generation versus millennial generation, you can find that out in the link below. So is there a significant difference in the proportions? Use alpha equals 0.05. Well, you could probably figure this out on your own after doing all of the two sample testing, and doing the one sample testing from chapter 9. So we go to tests, we go all the way down to the 2 proportion z-test. All right. Now, one thing I will do here before I get too carried away on actually my calculator is I should set up my null and alternative hypothesis. We know we're dealing with proportions. So we know that's our test. Okay, so before I get too carried away, let's set up my null and alternative hypothesis. So what I'm going to do is I'm going to say the proportion of group 1 is equal to the proportion for group 2. All right. Now, which one are we calling group 1 and which one are we going to call group 2? Let's call the boomers group 1. Whoops. And the millennials group 2. All right. And this is just asking, is there a significant difference? So as far as difference goes, that's sort of a indicator that when we take the proportion of group 1, difference is just saying, are we not equal to the proportion for group 2? Okay, so difference is an indicator that we're using not equal to in the alternative hypothesis. Okay, so proportion from group 1 equal to proportion from group 2. Notice again, we're using prop. We don't want to use p because that's a p-value that'll get confused. We also don't want to use mu because mu means average, and we're obviously not talking about averages anymore. We're talking about proportions. So we turn to our calculator. This is a 2 proportion z-test. When you look into it, the x1, n1, well, that's going to be exactly the same as what we had from chapter 9. It's going to say, well, 75 successes out of 357 boomers who were surveyed. Again, I'm using the 357 and 75 for group 1 because I said the boomers were group 1. All right, so x1 is 75, n1 is 357. Now x2 is going to be 28. 28 of the millennials had been veterans out of the 700 that they surveyed. So 28 is my x2, 700 is my n2. We're going to click on the not equal to and then go ahead and calculate. Now I'm just going to show you my display on my calculator real quick before I move on. Hopefully I can click the right thing here. There we go. That's the display you want. And then we calculate. And I got a very small p-value. My p-value is 1, well, let me actually do this in 1.18 times 10 to the negative 18. That is an extremely small p-value, okay? Almost, it's very, very close to 0. Think about how many zeros. You'd have to have 17 zeros after your decimal point to write that. So clearly this p-value is less than alpha. Okay, alpha is 0.05. So we're much less than alpha. So the conclusion is to reject the null hypothesis, reject H0. If I reject H0, I say that can't happen. Therefore, the alternative hypothesis must be happening. Now, what does that mean? That means, whoops, the proportion of boomers who were veterans is not equal to the proportion of millennials who are veterans. And we can see on our calculator all of these displays. There's a ton of displays. I just want to mention a couple. Sorry, trying to multitask and looking at my calculator and typing at the same time. So the proportion of boomers who are veterans is not equal to the proportion of millennials who are veterans. Just one little note on my screen on my calculator, you can see that there. There's a p value, there's p1, there's all kinds of other things. The p-value there is at the top, 1.18 times 10 to the negative 18th. P1 is 0.21. P1 hat, I'm sorry, is 0.21. That's the proportion of boomers from the sample that were veterans. So about 21% of the boomers were veterans that we sampled, and about 4% of the millennials who we sampled were veterans. So that's what the P1 hat and the P2 hat. If you look at the combined P hats, well, that's basically if I combine these all into one big group, that would be the proportion from the big group. So that's the idea. All right. Again, be careful when you're writing this on the test. It's prop 1 equal to prop 2. Don't try to skip on that. Don't try to write mu. Don't try to write something else. So what I'd like you to do is push pause on the video, try example 10. All right, so we're looking at solo parents here, and we're looking at the proportion of solo fathers who are white, and we're looking at the proportion of solo mothers who are white. Okay, now why would we care about this? Who knows? Who knows? I really don't. It's just a weird statistic that we saw that came up here. So again, this is not being pro or anti solo fathers or solo mothers or pro or anti being white. It's just something people look at. Again, reiterating something we talked about way back in chapter 1. All right, so let's go to this. Now, here's where we're going to look. We're going to look at the proportion of solo fathers who are white and proportion of solo mothers who are white. So fathers we'll call group 1 because they showed up first in the wording of the question. And we will call the mothers group 2. Okay, so we're talking about proportions once again. And we take the proportion of fathers who are white is equal to the proportion of mothers who are classified as being white. The alternative, well, we're just looking for a difference And so what we do, just looking for a difference, so we're going to use not equal to in the alternative hypothesis. Okay, this is clearly a proportion test with 2 samples, so it's a 2 sample, or it's a 2 prop z-test, 2 proportion z-test. But again, we just call that a 2 proportion test sometimes. So 2 proportion test or 2 proportion z-test, and there we have it. Whoops. Now, when you type things in, we called fathers group 1, so the number of fathers, X1 should be 161, N1 should be 644. The number of solo mothers, 183 should be my X2, 763 should be my N2. We're going to use not equal to, and then we're going to calculate it. So again, we'll just flash the screen in front of you. There it is. Calculate that. And I got a p-value of 0.6587. That's a fairly big p-value. Remember, our p-value is an area under the curve, so getting something that's 0.6587 is pretty large. And so my p-value is bigger than my alpha. That means do not reject the null hypothesis. All right, so don't reject the null hypothesis. What we're saying is that the proportion of solo fathers who are white is close to the proportion of solo mothers who are white. I'm writing this as fast as I can. All right, so the proportion of solo fathers who are white is close to the proportion of solo mothers who are white. Okay? Again, does this mean that we're anti one group or anti another? Of course not. It's just the statistics. Okay, so they are close. The proportion of solo fathers who are white is close to the proportion of solo mothers who are white. Key things that I need you to have when you write this stuff down, I need to make sure that we're talking about proportions. I need you to make sure that when we don't reject the null hypothesis, don't write equal, write is close to. Okay, that's an important distinction. All right, that is close to is an important distinction when we write down our interpretation statement. Okay. All right, let's do one last problem here. Try to push pause, do the problem, and then come back and see what you got. All right, hopefully you went through that. We're talking about in a sample of 800 US adults, 44% said they trusted the people from holistic groups when talking about vaccines. In the same sample, 49% said they trust the pharmaceutical industry leaders when talking about vaccines. Does a lower percentage of US adults trust holistic groups than pharmaceutical leaders? All right. So, same group tested twice, But that's okay. This is not a paired data thing. They're just testing those 800 people. They're saying, do you trust holistic groups when talking about vaccines? Do you trust pharmaceutical leaders when talking about vaccines? And then it says, does a lower percentage of US adults trust holistic than pharmaceutical leaders? So let's actually go to the actual problem. What we're going to be looking at is the proportion of adults who trust holistic leaders versus the proportion of adults who trust pharmaceutical industry leaders. All right. So think about this. Group 1, we'll call those who trust holistic, the proportion who trusts holistic. Group 2 is the proportion who trusts the pharmacies or pharmaceutical. All right. Now we're saying, does a lower percentage of US adults trust holistic than pharmaceutical industry leaders? When you get this, since we called those who trusted holistic as group 1, we're just asking, does a lower percentage? So we're going to have to say, since group 1 is the percentage who trust holistic, or the proportion who trust holistic, prop 1 less than prop 2 is going to be my alternative hypothesis. Hopefully that all makes sense. Now, obviously, we have two prop Z test here with our test. So we go there, and here's a little bit of a twist. It's the same twist we had in chapter 9, so you can probably figure this out. We said that 44% of the 800 trust in the holistic. That was group 1, right? Those, which percent trust in holistic? And 49% of that same 800 trust in pharmaceutical leaders. Okay? So what we have to do is we have to not input the percentage, we have to put in the number of successes. And so what we're going to utilize is knowing that when I type in X1, actually let's go to another one here. When I type in X1, I'm going to have to type in 352. And the reason I do that is because that is 44% of that 800. And in the same way, when I type in the X2, I'm going to have to type in 392 because that is 49% of the 800. Okay, so you can do this within the testing feature in your calculator. You can also do this by hand on the outside. But in any regards, X1 is going to be 352, N1 is going to be 800, X2 is going to be 392, N2 is going to be 800. When you utilize your alternative hypothesis, remember we're using less than. So again, I'll flash the screen here as soon as I can hit it. So that's the screen. And my p-value comes out when I calculate as 0.0225. let's compare that with the alpha. The alpha was 0.05. So 0.0225 compared to 0.05, that means that P is less, P is less than alpha. P less than alpha means that I should reject my null hypothesis. If I reject my null hypothesis, then the alternative must be true. So the proportion of Americans who trust holistic or alternative groups is less than the proportion of Americans who trust pharmaceutical leaders when talking about vaccines. All right. So there it is. I skipped the typing there just to speed things up. The proportion of Americans who trust holistic or alternative groups is less than the proportion of Americans who trust pharmaceutical leaders when talking about vaccines. Again, we're talking about proportions, and it's really important that we have the less than in there, right? That the proportion of Americans who trust holistic groups is less than the proportion who trust in pharmaceutical leaders when talking about vaccines. Again, this is not making a judgment on any case, whether people should trust holistic groups or should trust pharmaceutical leaders. This is just a statement of fact, not a statement of opinion. So that is it as far as Chapter 10 goes. Okay, review the material on Chapter 10. Chapter 11 will, or excuse me, Chapter 11 we're going to skip. When we come back, Chapter 12 will be a very different type of material. It won't be testing anymore. It'll be regression and correlation. All right, so make sure you make sure you've taken notes on all the videos. Also, make sure that you finish your homework and do all of that kind of stuff online too.